Hey Lorenzo, how are y'all today? Awesome. Um, so I was just going over problem number 29 with the student that's in here. Um, so she'll be joining us today, but I'm going to be reserving uh, to y'all's questions. She's going to be in here observing with us. Um, so what's going on today? Today we begin our process of reviewing for the final exam. We're going to do this today and on Wednesday. Um, the only thing that you have to turn in this week um, is your notes and homework for assignment 26, determinants and Kramer's rule, what we talked about yesterday. Y'all weren't here yesterday. I hope everything of y'all's um, academic affairs went well. Did everything go good yesterday with what y'all were doing? Good. Glad to hear that. So, what's on the table? Your questions. Now, these questions can come from the review, from any of the exams, any of the homework, any of the quizzes. We can go over whatever you want. And so, um, this is all getting recorded. So if you want to go back and look at things again, or go back and look at my 9 o'clock class recording, the 9 o'clock class, and you can see what we cover in that one. So we may cover some different things, and we're going to be doing this today and Friday. So, enough of my talking. What can I help you with? What questions do we want to bring to the table?
Can we go over question number 4, please?
Did you say 4? Run the review. Correct? Okay. Here we go. Problem number 4 from the review. We have 9 over x plus 2 plus 2x over x minus 1 is equal to 6 over an x squared plus x. No, oh yeah, we're good. Minus 2. Okay. Now, this is coming back, way back from Unit 1. And what we should start recognizing is that if we were to factor this trinomial, we're going to get the product of these two guys. At least we should, hopefully. Let's verify that. What are the factors of negative 2 that add up to 1? How about a positive 2 and a negative 1? And lo and behold, that's the same denominators that we have over here and here. So, first of all, this makes our LCD. And what we're going to do is we're going to multiply this entire equation through by my LCD. So we're going to multiply it through by the x plus 2 times the x minus 1. Every single term in this equation is going to get multiplied through by my LCD. Why? Because we don't like the fractions. So how do we get rid of fractions? We multiply it through by the LCD. So when I distribute this LCD, I end up with the following. The x plus 2's cancel out, leaving me with x minus 1 times 9. Plus, when I distribute the LCD, the x minus 1's cancel out, leaving me with x plus 2 times a 2x. Equals, when I distribute, the x plus 2's cancel out and the x minus 1's cancel out, leaving me with 6. Then, what I can do is I can start getting rid of my parentheses. So I can distribute. That's going to give me 9x minus 9 plus a 2x squared plus a 4x equals 6. Let's combine some like terms together. 2x squared, a 9x and a 4x make a 13 minus 9 equals 6. And now I recognize, oh, this is a quadratic equation. That should be 13x. This is a quadratic equation. How do we solve quadratic equations? We set the equation equal to 0. So when I subtract the 6 on both sides, negative 9 minus 6 is going to be a negative 15 equals 0. So now the question is this: how do I solve this quadratic equation? Now I could use the quadratic formula, but I'm going to choose the factor. Alright, so if I use the AC method, I'll put my x and x right there. So I'm going to ask myself the question, alright, 2 times negative 15 is a negative 30. What are the factors of negative 30 that add up to a positive 13? Well, factors of negative 30 that add up to positive 13. Oh, there we go. How about a positive 15 and a negative 2? But we got to divide these by 2, because we're using the AC method, so that means that we have x. Let's see, that means we get 2x plus 15 times an x minus 1 equals 0, which then if I set each factor equal to 0 and solve, we get x is equal to, subtract 15 divided by 2, negative 15 over 2, and then x is equal to, add 1 to both sides, x is equal to 1. And before I box this in, I'm just going to come back over here. I'm going to make a note to myself. Here's my note to self. Note that x cannot equal negative 2, because if x equaled negative 2, negative 2 plus 2 would be 0. You cannot divide by 0. And note that x cannot equal 1, because 1 minus 1 would be 0. You cannot divide by 0. And since my answer's here, we do have a conflict of interest, don't we? What's 10% remaining? And it's still charging. Alright, never mind. I think we have a typo in the answer key, because the answer key says that x can equal 1. But I think we have a problem, because x can't be 1 right there. So, yeah, we got to throw that answer out. So our only answer is the negative 15/2. So, did you come across that in solving? Yeah? Is that why you brought this to our attention? Alright. So, I'm going to make note of that. I got my book right here. I need to make note of that problem. I need to make note of that. So, review corrections. Problem number 4, answer is only the negative 15/2. X cannot equal 1. Alright. So I've made note of that. I will get that corrected on the key, whenever I get around to it, today. So it may be after lunch before I get an opportunity to do that. Thank you for showing me that issue. Good eye. All right. What else can we look at?
Can we go over 55?
55. Oh, uh, while I'm thinking about it, um, while I'm thinking about it, from the review, you can omit / ignore. What were those problems? Last three: 71, 72, and 73. We can ignore those problems. We're not going to deal with them. Um, so, anyways, so you said problem number 53. Is that what you wanted to look at?
55.
55. Okay. So let's go back to the review. Problem number 55. I have the log base 2 of 2x minus 4 plus the log base 2 of x minus 2 is equal to 1. Okay, so we have a logarithmic equation here. Now, the first thing that I want to do, if I have multiple logarithms in a logarithmic equation, I want to condense. We want to condense. Now, to condense, we're going to use the product or quotient rule. Since we have a plus sign right here, this means we're going to use the product rule. So, what does this become? This becomes the log base 2 of 2x minus 4 times an x minus 2 equals 1. And if I want to, I could go ahead and FOIL this all together. Log base 2 of 2x times x is a 2x squared. 2x times negative 2 is a negative 4x. And then we're going to have another minus 4x, so that's going to be negative 8x plus 8 equals 1. Now at this point, we got to ask ourselves, how do we solve this? Well, what we're going to do is we're going to pull in that relationship between logarithms and exponents. So recall that for the log base b of x equal to y, this is equivalent to b to the y is equal to x. We're going to use this to rewrite this equation in the exponential form. So in the exponential form, this becomes 2 to the 1 is equal to 2x squared minus 8x plus 8. So 2 to the 1 is just 2. So I'm going to set this equal to 0. So that becomes a positive 2. So we're going to subtract 2 on both sides. That's going to give me plus 6. So now we need to factor this guy. All right, so you could use the quadratic formula. I'm going to go straight to the factored form. I know I need a 2x and an x because 2x times x makes 2x squared. And we need the factors of 2 times 6 is a 12. Factors of 12 that make a negative 8. Well, negative 2 and negative 6. So if I put a negative 1 right there and a negative 6 right there, I think that's going to do it. Let's double check. 2x times x is a 2x squared. 2x times negative 1 is a negative 2x. 6 times x is a negative 6x. Those combined together give me negative 8x. And negative 6 times a negative 1 is a positive 6. So there's the factored form. So this means that either 2x minus 6 is equal to 0 or the x minus 1 is equal to 0, which then means x is equal to add 6 divided by 2, that becomes 3. So add 1, x is equal to 1. I want to check real quick. I got to check because number 1, you cannot divide by a negative. You can't take the logarithm of a negative number. Make sure that you check. Why do we check? I mean, back over here, you saw that we got to check because we found that x equal to 1 is an extraneous solution. Check. So let's start with 3. 2 times 3 is 6, minus 4 is 2. I can take the logarithm of 2. 3 minus 2 is 1. I can take the log of 1. So that works. What about 1? 2 times 1 is 2, minus 4 is negative 2. I cannot take the logarithm of negative 2, so automatically I'm going to throw that answer out. Now I can check by hand, but I'm just going to leave it for you to do that. I'm going to just verify that x is equal to 3. Done. If you check real quick, 3 times 2 is 6, minus 4 is 2. Log base 2 of 2 is 1. And then 3 minus 2 is 1. Log base 2 of 1 is 0. 1 plus 0 is 1. And there we go. Does that make sense? Okay. What else can we look at?
$59.
Say that again.
59.
65.
59.
55.
59, please.
59. $27x is equal to 1/3. Now, so there's two ways to do this problem. Number one, the heading of this says to solve using the calculator to make decimal approximations where necessary, round to 3 decimal places. So, I've already made the exam, and a problem like this would be in the solve section, where the only instruction I say is to solve. So there is an exact answer to this that could be found without a calculator. But if you use a calculator, I can't, and your calculator answer is correct, I can't say that's wrong. So how would you solve this with a calculator? Well, the first thing I would do is recognize that my variable x is way up there in the exponential position. So how do we get x out of the exponential position? Well, we first of all take the natural log on both sides. And then that allows us to utilize the power rule for logarithms. So we can then say, after we take the natural log on both sides, that x is equal to x times the natural log of 27 is equal to the natural log of 1/3. Now, then to solve, what we would do is we divide both sides by natural log of 27, so you get the natural log of 1/3 divided by the natural log of 27. Now, I suppose that if you wrote this answer down, I would have to count this correct. But I want us to give the decimal approximation. So in my calculator, I'm going to show you my calculator right here. Make sure that you do things exactly the way I do. When I do the natural log of 1/3, make sure that you close the parentheses around the 1/3. Close parentheses. Divided by the natural log of the 27. Now this is what we get. Negative 0.333 repeating. And it says to round to 3 decimal places, so that's 333. Now, I hope that we all recognize that negative 0.333 repeating is a negative 1/3. I hope we all recognize that. Yeah? Alright, so can I get negative 1/3 without using a calculator? Yes. Without using a calculator, this is a particular problem where I could rewrite both sides of this equation using the same base. So 27 is equal to 3 to the 3rd, and 1/3 is equal to 3 to the negative 1. So that means that I can rewrite this as 3 to the 3rd raised to the power of x, because that's 27. 27 to the x, that's 3 to the 3rd is raised to the x, is equal to 3 to the negative 1. Which then means I have 3 to the 3x is equal to 3 to the negative 1. And what we can say is this. If b to the a is equal to b to the big B, if you have the same base on both sides of your equation, so b to the a is equal to b to the b, then big A has to equal big B. So that means for us in this particular problem that 3x has to equal negative 1. And how do you solve for x here? We need to divide both sides by 3, so we get x is equal to a negative 1/3. So, I have to stick with what I say in the exam. And in the exam, if this was a problem in the exam or a problem like it would be under the solve section. So, I would accept this answer. I would also accept, I would have to accept this answer. But I hope that when you see that you do the decimal approximation of this, that you get that's the true way to express 0.33333 repeating, and so that makes your answer actually x is equal to negative 1/3. Alright, does that clarify problem number 59? Okay, cool. What else can we look at?
Number 63, please.
63. Cool. We have a 3x3 system. So I have not two, but I just have x plus 2y plus 2z is equal to 5. Then I have 2x plus 4y plus 7z is equal to 19. And then I have negative 2x minus 5y minus 2z is equal to 8. And so, much like the instructions here, for the final exam, I'm just going to say solve. So, I'm not telling you how to solve this. You can use Cramer's rule, you can use substitution, elimination, you could convert this into a matrix and get that diagonal of ones. That's called Gauss-Jordan elimination. We can do this however you want. So I'm going to leave this question up to you. How do you want to solve this system? What method do you want to use?
Substitution.
Alright, so we're going to solve this without thinking about Cramer's rule, without matrices. Fine with me. Let's do this. Substitution and elimination. Alright, so here's what I would do. I love the fact that I have a 1x right here. And I also love the fact that I got a positive 2x and a negative 2x. So here's my plan. I'm going to eliminate, pretty sure I spelled that wrong. I'm going to eliminate the x's with two sets of equations. Alright, so I think the first one might be fairly obvious. Equation 2 plus equation 3. Now I think we can just do this right here. 2x plus negative 2x is going to be 0. 4y minus 5y, that's going to be a negative 1y. 7z minus 2z is going to be a positive 5z. And 19 plus 8 is going to be a 27. We're going to call this equation 4. Now, I want to make my x's go away with two other sets of equations. And I'm going to use this negative 2x to my advantage, and I'm going to use this 1x to my advantage. So I'm going to take 2 times equation 1 and add it to equation 3. So I'm going to take the time to rewrite this out. 2 times equation 1 is going to be 2x plus 4y plus 4z is equal to 10. Equation 3 is still the negative 2x minus 5y minus 2z is equal to 8. Add these equations together, my x's cancel out, just like I wanted to. Then we get 4 minus 5y is a negative 1y. 4 minus 2 is going to be a 2z. And then 10 plus 8 is going to be 18. We'll call this equation 5. So, I now have equation 4 and equation 5. So, what we just did is we just created a 2 by 2 system. I'm just going to write that off over here. Negative 1y plus 5z is equal to 27. And then negative 1y plus 2z is equal to 18. Just double checking, making sure that we look good. I think we look good so far. Yeah, I think we look good so far. Alright, so now we gotta solve this system. Alright, so what would I do to solve this system? I might think about elimination. Elimination tends to be my favorite way to do things. So what if I take negative 1 times equation 4 and add it to equation 5? Because that's going to create a positive 1y minus 5z minus 27, and then I have negative 1y plus 2z is equal to 18. My y's cancel out, and then I get a negative 3z is equal to, alright, the difference between 27 and 18 is 9. That's going to be a negative 9. Alright. Now I can start getting my values for x, y, and z. Negative 3z equals negative 9. That means z has got to be equal to 3. Right? Z has to be equal to 3. So then I can work backwards. So maybe if I come back up here to equation 4, where I have negative 1y plus 5 times a 3, it's positive 3, is equal to 27. So I'm plugging in z is 3. This gives me negative y plus 15 is equal to 27. So that means negative y is equal to, subtract 15 on both sides, that gives you 12. So that means that y is equal to a negative 12. Okay? So I got z, I got y, and then we need to go back and find x. So I'm going to come all the way over here to equation 1, where we have x plus 2 times a negative 12 plus 2 times 3 is equal to 5. So x minus 24 plus 6 is equal to 5. So we have x minus 18 is equal to 5. So we're going to add 18 to both sides. X is equal to a 23. And there we go. X, Y, and Z. That lines up with the answer key. So there's just one way to solve this. How else can you solve this? You could convert this into an augmented matrix and then use Gauss-Jordan elimination, or you could convert it to augmented matrix and use Cramer's rule. Now I know that y'all weren't here yesterday, but hopefully y'all went back and watched the lecture videos for at least for our 9 o'clock class, and assignment 26 makes sense. Is that correct? Are we good with assignment 26, Cramer's rule? Good. Alright, so does it make sense how I approached, well actually, I approached this problem by your method using substitution and elimination. Does it make sense? Okay, what else can we look at?
18.
18. Okay, 18. We have negative 2 times the absolute value of 5 minus x closed absolute value is less than a negative 6. Alright, first thing that we want to do is we want to isolate the absolute value expression. We want to get the absolute value of 5 minus x by itself. So how do we do that? We're going to go through and divide by negative 2. Now, that's going to get rid of the negative 2 here, so you're going to have absolute value of 5 minus x. Negative 6 divided by negative 2 is a positive 3. But what happens when we divide an inequality by negative? We have to change the direction of our inequality symbol. So we have to rewrite this as absolute value of u is now greater than 3. I'm just going to highlight this. Change the direction of your inequality symbol. Why? Because we divided by a negative. Alright, so now we can proceed. So, real quick review, recall. There's two situations that we have to be aware of when it comes to solving absolute value inequalities. If the absolute value of u is less than d, then we say that negative d is less than u is less than positive d. What we do is we sandwich the expression inside our absolute value between the positive and negative of whatever d is. That's for the less than. If the absolute value of u is greater than d, then we have two statements. Either u is less than negative d, or u is greater than d. So these are the two statements that we have to be aware of when it comes to solving absolute value inequalities. That's what we have to be aware of when we're solving absolute value inequalities. So I'm looking at my situation, and I see the absolute value of x minus 5 is greater than 3. So that means I'm going to use this statement right here. So we then say, we have two things to say. We then say that 5 minus x is either less than negative 3, or 5 minus x is greater than 3. Those are our two inequalities that we have to solve. Alright, so let's go forth and solve these. First of all, we're going to subtract 5 on both sides. Now, I don't want to know what negative x is, I want to know what positive x is. So what are we going to do? We're going to divide both sides by negative 1. But that's going to change not only this 8 to a positive 8, but it's also going to change the direction of this inequality. X is greater than 8. And then, over here, we're going to subtract 5 on both sides. So that's going to give me negative x is greater than a negative 2. But I got to get rid of that negative sign, so we're going to divide or multiply both sides by negative 1. And that's going to give me x is less than positive 2. Alright, so to write your answer in interval notation, I first like to graph. So on a real number line, now I know we got 8 first, but that's not what comes first on the number line. On the number line, 2 comes first and then 8. We're going to use open circles because it's strictly greater than or strictly less than. If x is greater than 8, we're going to shade to the right. If x is less than 2, we shade to the left. So that's what the graph of our solution set looks like. How do we express this in interval notation? Well, this interval is everything from negative infinity to 2 with the parenthesis, union with the interval from 8 to positive infinity. And that's how we solve this absolute value inequality. Does that make sense? Okay. I like seeing those thumbs ups. Alright, what else can we look at?
Can we go over 68?
Did you say 58 or 68?
68?
58.
60, like 6.
Oh, sorry.
It's okay.
It's alright, 68. Find the inverse of f of x is equal to 3x minus 4. Okay. So, the first thing that we want to do, I'll write this out with steps. Step number 1, we want to take that f of x and make it a y. So that becomes y is now equal to 3x minus 4. Then step 2 is we now want to swap x and y. So this now becomes x is equal to 3y minus 4. Now, third step is to solve for y. So from this equation, I got to get y by itself. So how do I start getting y by itself? Well, the first thing I might do is add the 4 to the other side. Okay? And then the second thing that I think I would probably do is I would divide everything by 3. Because that's going to get rid of my 3 that's hanging out with my y. So this becomes x plus 4 over y, over 3, is equal to y. Okay? And then step number 4, take y and replace it with your function inverse notation, f inverse of x. And we now get f inverse of x is equal to x plus 4 over 3. Now, how do we verify that these are inverses of each other? Well, one quick way is you could do some test some values. I mean, this would be a quick way to do this. So, let's do real quickly f at, doesn't matter, pick a point, f at 2. Well, f at 2 is going to be 3 times 2 minus 4. And 3 times 2 minus 4 is going to be 6 minus 4 is 2. I don't think I like that because you plug in 2, you get out 2. So let's pick a different value. Let's pick 3. Alright, that'll be better. 3 times 3 is 9, minus 4 is 5. So If you plug in 3, you get out 5 in f of x. Now, if we did things correctly, that means f inverse of 5 better be 3. So 5 plus 4 divided by 3 is 9 divided by 3, which is 3. So you see that? This is a quick way to test whether you got an inverse function. Pick a point, plug it into the original function, you get your output, then take that output and plug it into the inverse function. If your output there is the same as your input over here, you got a inverse function. Now, the problem with this is you got to do this for infinitely many points. So if you do this again for maybe one more point, you can probably be assured that you have the correct inverse function. Another way to test this is the following. Here's our true verification, which I'm not going to go through. Here's our true verification. F of f inverse of x better be equal to x, and f inverse of f of x also better be equal to x. Meaning, if I plug in this function into this, I better get x out as my answer, and if I plug this function into this, I better get x out as my answer. I'm not going to go through and do that. I mean, you could do that on your own, but there's your answer to this equation. Problem. Does that make sense? And, these are the steps that you need to know. Swap, or replace f of x with y, swap your x and y, solve for y, and then replace y with f inverse of x. Okay, cool. What else can we look at?
12.
12. Cube root of 3y is equal to y. Oh, cool. Alright, so the first thing that I would say if I presented this equation to y'all, I would ask the question, what do we not like about this equation? And hopefully y'all would say the square root. So how do you get rid of a square root? You square both sides, right? Square both sides. Now, what does that produce for us? If we square both sides, that gets rid of the radical. So this leaves me with 3y is equal to now y squared. Now, all of a sudden, we now have a quadratic equation. And how do we solve quadratic equations? We set them equal to 0. So we have y squared minus 3y is equal to 0. Now, how do you solve this? I mean, this is not a trinomial. We could factor trinomials, but how do you solve this? I mean, you could use the quadratic formula. You could say that a is equal to 1, b is equal to negative 3, and c is equal to 0. And you could use the quadratic formula. Or I could recognize that I have a GCF of y. So if I factor out my GCF,
Your conference is scheduled to end in 2 minutes.
Thank you. Y times y minus 3 is 0, which then means that y is 0 or the y minus 3 is 0. So you get y is equal to 0 and y is equal to 3. And there are your solutions to this problem. I'll double check real quick. If I plug in 0, 3 times 0 is 0, square root of 0 is 0, 0 is equal to 0, check. If I plug in 3, 3 times 3 is 9, square root of 9 is 3, equals 3, check. And there it is. Alright, so we don't have any more time to do any more problems today, but we got Friday. So again, on Friday, we're going to be doing the exact same thing. Bring your questions to the table. Remember that you can refer to your exams, quizzes, homeworks. We don't have to just look at the review. So if there's other things that you want to look at, bring them to the table. And we'll do this on Friday as well. Note again that you can utilize the recording for my 9 o'clock class as well. They may, in that class we may go over questions that you didn't think about, or maybe you just want to watch it and say, oh, that's a good point. So lots of resources for you to look at. So I will see you
Your
all
conference
on,
is now over. Goodbye.
I'll see you all on Friday. Bye.